This is the homework 2.2 practice. First part here is telling me, you have to tell me which is the explanatory, which is the response. Explanatory is what we do to something. Response is what we measure afterwards. Okay, so amount of time studying for an exam and the grade on the exam. The explanatory would be what we do first. We study, so the amount of time we have. The response would be the grade that we get on it. That's the measurement. Corn yield in bushels per acre and the amount of rain. The rain comes first, so we're going to measure that amount of rain that we get. The response is how much corn is there. So the more rain, the more corn yield usually. Okay. Number 3, arm span and height of high school seniors. Really doesn't matter which one's first and which one's second. It could go either way. Height and arm span could be intermixed there. Same with number 4, the number of texts and the number of cell phone calls. Once again, they could be either way. Sometimes it matters, like this is something that happens first, and then there's the result of that. Number of texts, number of calls, one doesn't depend on the other at all. So it can be mixed up there. Okay. Okay, with this problem here, we have a bunch of different roller coasters, how high they go and the maximum speed. Generally, your explanatory variable is going to be listed first, and then your explanatory second. It's sort of like your x and your y. Okay, but also the height is what influences the speed. Okay, so explanatory is going to be our height, and then the result is our max speed. Okay, so we first have to decide here, okay, height, let's go, looks like, I'm going to go by 50s, so 50, 100, 150, 200, 210, 250, 210 is the highest there, and the speed, I'm going to go like this to kind of signify that there's a break in there. Okay, so I'm going to start here at, oh, it does go down to 20. Let's go 20, 40, 60, 80. Okay, that's just the scale I use. You can use something different. Okay, so we want to plot our points here. Actually, I wouldn't have to put that 20 because I did go by 20, so I don't have a break there. It'd be 0. Okay, so I plot these. If the height's 100, we went 55 miles an hour, so about right there. 196 and 83, roughly there. 70 and 55. Whoop, this should be level with each other. 50 and 24. It's a little mini coaster. 192 and 66, 152 and 65, 152, 131 and 50, 210 and 61. Okay, so that's roughly what their scatter plot looks like. And that's all you had to do for that problem. But if you wanted to describe it, let's just go and do it just so for the fun of it. Okay, to describe it, I'd say it was fairly strong. No outliers. Form is linear. It's a straight line there. And the association is positive. The higher the coaster goes, the more speed it gets. Okay, so that's that problem. Okay, so for number 6, we have state SAT scores, the percent of people taking the SAT, and the mean math score. Okay, so we want to describe the relationship. So whenever you want to describe it, you're thinking SOFA. Okay, so the strength, outliers, form, and association. Okay, so strength. So by looking at this, Well, first of all, we kind of see a curved pattern here. So the form, we can talk about that. But strength, I'd say they're grouped together pretty well around each other to form a pattern here. So I'll say fairly strong. Okay, outliers. I don't think these are too far out of the way to consider them outliers. So no outliers. They're possible outliers, but I don't think too much. Form, we see kind of a curved pattern to this. So that curved pattern makes it nonlinear. And the association, as this percent increases, this decreases, right? So it's kind of a negative correlation. Okay. So when there's more people taking the SAT, when the higher percentage of people take the SAT, the average grade goes down. Usually if there's just a small percentage of people taking it, that would be the people that really have studied a lot for it and a little smarter maybe. And then if there's a whole lot of people taking it, if everybody takes it, the average grade usually goes down a little bit. Okay. Okay, number 7, actually, we already did it kind of in the last one. We're supposed to look at this, and we're supposed to describe it, okay? So we said it was a strong, linear, positive correlation with no outliers. Okay, strong, positive, linear, no outliers. Okay, so that's how you describe it. Think SOFA. Okay, these last 2 problems here. Okay, this one, number 8. Draw 2 scatter plots with positive linear associations. Okay, so positive going up in a linear fashion, but with different strengths. Okay, so this one is positive, it's linear, and it has a pretty strong correlation. Whereas this one here is positive, it's linear, but it has a weak correlation. So this is strong correlation, and this one has a weak correlation, very spread out. Okay, last one. Explain what it means if there is a negative association between the amount of fuel that a furnace uses and the outside temperature. Okay, so if I get a visual for this, if I think about the temperature, it will impact how much fuel I use. So the temperature is my explanatory, and the amount of oil I use will be my response. Okay, so as my temperature increases, okay, so if it's really, really cold out, if it's 0 degrees, I'm going to have to use a lot of oil. As it gets warmer, I'm going to have to use less oil to heat my house because it's not as cold outside. So I would have a negative association. Okay, so what does that mean? It means as the temp increases, the amount of oil used decreases. Okay, so that is the homework.